Hello, everybody. It's a pleasure for me being here and presenting joint work with my advisor, Abraham Bernstein at the University of Zurich. So the internet changed the way and the scale and scope as humans and machines can collaborate. We are able to build together one of the largest encyclopedias. We can find new solar systems in galaxies too. Or we can earn some money on Amazon's Mechanical Turk, and I'm really excused for this bad resolution. There's something wrong with the technique here. Or last but not least, we can have a lot of fun in playing one of Louis Fonan's ESP games and therefore help to label and tag all the images on the World Wide Web. And we believe that as these networks of humans and computers will increase, it will be commonly useful to view them as constituting something like a global brain. But when we try to program new systems for this global brain, we have some problem. We need a Wizard of Oz, somebody who knows to design these systems, somebody who knows how the crowd and the machines can interact. For me as an engineer, that's quite difficult. It's for me especially difficult to understand how humans work. Humans are profoundly different than machines, so they work because of different motivations, such as joy, altruism, or money. There's a large cognitive diversity among humans. Some are better or well educated, others not. We have different cultural backgrounds, which is important for a lot of questions. And last but not least, if I have to solve a complex mathematical term, I will possibly do that better in the morning than in the evening because I'm tired and therefore will produce more errors. And computer never gets tired and always will provide us with the correct answer, but therefore he cannot answer all the questions. So we address this problem by introducing CrowdLang. CrowdLang is a programming framework and language to interweave humans and machines in complex systems. It's important to say CrowdLang is more than loops, conditions, or sequences. It's about new programming abstractions for handling humans in the loop. For example, group decision processes, or things like how to elicit truthful answers. Further, we try to implement a sort of a specificity frontier, where you have, on the one hand, clearly defined and structured algorithms, and on the other hand, just common goals. So I want to go to Chicago, make some holidays for $1,000, but how to solve these problems I do not exactly in the first step, but possibly when the process goes on, we will remain in an algorithm which is highly defined. And additionally, we have things like how to manage the crowd latency, the integration of different crowdsourcing platforms, and so on and so forth, but that's off the topic for this talk today. So how does it work? I will show you in a little example. Assume the following situation. You have a book in German, and you want to have translate that into English. The only two things I will get you is a machine translation software and a large crowd of monolingual workers, meaning they only know English. Now, how to implement such a system? Well, by programming with CrowdLang, we follow a simple development process. We start with defining an abstract problem-solving algorithm without thinking about incentives, about group consensus, and so on. So we have an article or the book. So we first decompose the whole task, first in paragraphs and then into sentences. Then we can process each of those sentences in parallel, which will accelerate our whole process. So we only have English speakers in our crowd. Well, then do some machine translation. Now, as we all know, this machine translation will be quite bad. What to do with that next? So we now will introduce crowd in a so-called rewrite task. That's something like the following. We present them a paragraph of translated text and ask them to translate or rewrite the red highlighted text in a way that they think it shows the right semantics and is syntactically and grammatically correct. Well, we do not bother about which we get the really good answers at this stage, assuming we have them now. So we have now the possibility to aggregate all these sentences into paragraphs and make some further steps on paragraph level, such as guaranteeing the fluency of the whole paragraph or enforcing consistent wording. And last but not least, we have to look that all the grammar and syntax in our translation will be correct, and hopefully we have a good translated text. So now we have these 3 blue boxes, what to do with them. Well, we have a whole library of group decision mechanisms and so on. For example, we can use something like a contest. So I give one sentence to 3 different persons and ask them to rewrite them. And then I use something like an aggregation mechanism, for example, majority voting or plurality voting, what else? And then try to elicit the best of those sentences. Or I can use something like iterative improvement. I give the sentence first to one person, then the output of this person to another, and so on and so forth. Or we result in really complex things like find, fix, verify, introduced by Michael Bernstein in 2010. So what CrowdLang then does is the following. We just produce a large amount of possible problem-solving algorithms. As you can see here, all enumerated. And we evaluate them on test data. And as a result, you will see we have 2 algorithms which clearly outperforms all the other ones. So how effective were they in practice? So we took John Grisham's book, Client, the German translation version, and translated it back into English. Well, we have done this for just $67. That's quite cheap. Within 1 hour, it was very fast and in good quality. So this was really impressive because if you give this book to a professional translator, he will have something between 1 and 2 months, and it will cost you about $10,000 to $20,000. And more importantly, if we use this translation as an input for the professional translator, he will finish up the work within 1 week. So something more about good quality. We have done some further experiments with open commentary articles. As a baseline, we use Google Translate as a professional translation as a gold standard. And we incorporated something about 2,000 crowd workers. And when evaluating translations, there are several things to consider, namely adequacy, fluency, and grammar. And then I will go into detail about the adequacy course we received with our translation, and can just say fluency and grammar will be in approximation the same results. So as you see here on the right side, the Google translation. The Google translation reaches something between 1.5 and 2 points out of 5 adequacy score over all these articles. Well, that's quite bad. The professional translation, in contrast, will get something between 4.5 and 5 points, depending whether a non-professional or professional translator have evaluated that. In between are our translations. We reach something between 3 and 3.5 points out of 5 with our translation software, and that's quite an important message, because we lost a lot of information and semantics with Google Translate, and we were able to reconstruct a lot of those information with the post-processing of our things. So, to conclude, CrowdLang leads us to a simple way to explore a large design space of possible human computation algorithms, which is quite nice because I'm not a Wizard of Oz, I'm an engineer. And last but not least, we hope that by introducing something like the specificity frontier, we will come away from this command and control structure we always have when we program to computers to something that is more about coordinate and cultivate communities. Thank you very much.